Hello students, let's see today some important multiple choice questions in real numbers. First chapter. Here, first question, if you see the sum of exponents of prime factors. Sum of exponents of prime factors in the prime factorization of 196 is. So here what you have to do, you have to find out the prime factorization of 196 first. So that is, you can take two table, 2 9s are 18, 2 8s are 16. Again 2 table, 2 49s 98. Again now 7 by 7, 7 sevens are 49, 7 ones are 7. So we can write 196 as 2 power 2 into 7 power 2. Here the question is we have to find sum of exponents of prime factors. So your prime factors are 2 and 7. Their exponents are 2 again 2. We have to find sum of exponents. So the result is 2 plus 2. Exponents are 2 and 2. 2 plus 2, that is 4. So sum of exponents of prime factorization, the prime factors in the prime factorization of 196 is 4. So the option B is correct. Now coming to question number 2, the total number of factors of prime number is, we all know a number which has only two factors, one and itself, is called prime number. So the number of prime factors of a prime number, or the number of factors of a prime number, is 2. So option C is correct. Coming to next question, that is question number 3. We have to find out LCM and HCF. HCF and LCM of 12, 21, 15 respectively are. So we know directly 12 is nothing but 3 into 4. 4 is 2 power 2. So we can write 12 as 2 power 2 into 3 power 1. 4 into 3. 4 is 2 power 2. So 2 power 2 into 3 power 1. Then coming to 21 is 3 power 1 into 7 power 1, because 3 sevens are 21. Then 15 is 3 power 1 into 5 power 1, 3 5 is a 15. Now when you want HCF of 12, 15, 21, when we write HCF, we have to select only common factors in all the prime factorizations. So 3 is there in all the three factorizations, so only 3 is the common factor, and we have to take its lowest power. Lowest power of 3 in all the three factorizations is 1. So here answer will be 3 power 1. 3 power 1 is nothing but 3 itself. This is what HCF. Now let us see LCM. LCM of 12, 15, 21. When we write LCM, when we find LCM, we have to write all the prime numbers in the factorizations. So 2 into 3 into 5 into 7. These are the different prime factors in the prime factorization of 12, 21 and 15. Now we have to take their highest powers. 2 highest power is 2 and remaining all highest powers are 1. So now that is 2 power 2 4, 4 into 3 12, 12 5 is 60, 60 into 7, 60 into 7 is 420. So LCM is 420 and HCF is 3. HCF and LCM they are asking. So the result will be 3 comma 420. Option C is correct. Now question number 4. We have to find out after how many places it terminates. So whenever question comes like this, see it is 11 by 2 power 3 into 5 power 1. In denominator we have to make it 10 powers to get after, to know after how many decimals it terminates. We have to make the denominator into 10 powers. So for that here 2 power 3 is already there, but 5 power only 1 it is there. So we need to multiply 5 power 2, because 5 powers are less, 5 factors are less. So 5 power 2 should be multiplied, so that we get it as 11 into 25 by 2 power 3 into 5 power 3. Okay, that is 25, 25. 11 into 25 is 275. So that is 275 by 10 power 3, which is 0.275. After how many decimals it terminated? After 3 decimals it is terminated. So now onwards we can remember, in the denominator when you have only 2's and 5's, prime factors, if the denominator, prime factorization of denominator contains only 2's and 5's, it will be a terminating decimal, and after how many digits it terminates depends on the highest power of 2 or 5. Here 5 power 1 we have, 2 power 3 we have, so we can make it 10 power 3 by multiplying 5 power 2. So when you are making 10 power 3, because you have in the denominator 10 power 3, the p by q form will terminate after 3 digits. So whenever it comes to objective, you can see directly what is the denominator and what is the highest exponent of 2 or 5. Here highest exponent is 3, so after 3 decimals it terminates. So the answer is C. Question number 5. Question number 5. The LCM of smallest two-digit composite number and the smallest composite number is. We have to find out what are smallest two-digit composite number and the smallest composite number. We know smallest two-digit composite number is 10. Smallest composite number is 4. Smallest composite number is 4 and smallest two-digit component number is 10. So 10 can be written as, 10 is nothing but 2 power 1 into 5 power 1 and 4 is 2 power 2. So LCM of 10 comma 4 is 2 into 5, and what is the highest power of 2? 2. Highest power of 5? 1. So it is 4 into 5, 20. 20 is the LCM of 10 and 4. No need to follow like this. If you know directly also you can answer. LCM is 20. So that option we have at the top. Yes, here option C is correct. Option C. Now the next question. HCF of two numbers is 27 and the LCM is 162. If one of the number is 54, then the other number is, this previous question option is C, 20. Now here we have, we know HCF of two numbers. Let us take A, comma, and one of the number 54. We don't know that another number. Let us take it as A. And we have HCF of A, comma 54 we know, and LCM of A, comma 54 also we know. We have to find out HCF of A, comma 54 is 27 is given, and LCM is given 162. We have to find what is that number. We have a concept, we have a formula. LCM of A, comma 54 into HCF of A, comma 54 is equal to product of two numbers, 27 into 162. LCM into HCF is equal to product of two numbers. We know that. So, okay. Now, what is the product of two numbers? A into 54. So, what we know that A into 54 is equal to 27 into 162. We want A. A is equal to 27 into 162 by 54. Now 27 ones, 27 twos, 2 ones to 80 ones. So therefore what is A? A is equal to 81. A is equal to 81. Hope you understood. This is also one of the important point we have to remember. LCM into HCF is equal to product of two numbers. Now the next question is to find out HCF of 144 and 198. So here again you can follow prime factorization or the division method, any method, because it is objective. So let I am going with prime factorization, two 72s, then again two 36, two 18s, again two 9s, three 3s. So 144 is equal to 2 power 1, 2, 3, 4. 2 power 4 into 3 power 2, whereas 198. 198 is equal to, we have to factorize it. It is 99. Then again 3 table, 3 33s, again 3 table, 3 11s. So 198 is equal to 2 into 3 power 2 into 11 power 1. We want HCF. When we want HCF, we take only common factors. HCF of 144 comma 198 is equal to, we have to take only common factors. We have the common factors 2, 3. So we have to take 2 into 3 and their lowest powers. Lowest power of 2 is 1 and lowest power of 3 is 2. So it is 2 power 1 into 9, that is 18. So HCF is what? 18. So option B is correct. Now next question, 225 can be expressed as. So 225 we know it is 15 power 2. If you know 225 as 15 power 2, it is simple. Otherwise you have to do again prime factorization. But I am writing, we know that 225 is nothing but 15 power 2. That can be written as 3 into 5 whole to the power of 2, that is nothing but 3 power 2 into 5 power 2. So 225 is equal to 3 power 2 into 5 power 2. Option is C. 5 power 2 into 3 power 2 or 3 power 2 into 5 power 2. Question number 8, option C is correct. Now let's see next question. Question number 9. Question number 9. In question number 9, again we have to decide what, after how many digits it terminates. So here just now we discussed 23 by 2 power 5 into 5 power 2 we have. So we can make it into 10 power 5. How can we make it into 10 power 5? By multiplying 5 power 3 in the numerator and denominator, that is 23 into 125 by 10 power 5, because denominator is 10 power 5, whatever numerator it may be, because question is after how many places it terminates. Because you have denominator 10 power 5, it terminates after 5 decimals. Or by seeing the question immediately if you want to answer, because highest power is 5, it terminates after 5 decimals. So the option is C. Option C is correct. Hope you understood this. Now the question number 10. Question number 10 also related to same concept again. After how many decimal places it terminates. Decimal expansion of the rational number 14,587 by 1250 will terminate after. So what? Take the denominator 1250, factorize it to 625, and we know 625 is 5 power 4. So what? Denominator is, we know 14,587 by, this is 2 power 1 into 5 power 4. Because denominator is 5 power 4, we can make it into 10 power 4 like before. How? By multiplying 2 power 3 in the numerator and denominator, we can make it 14,587 into 8 by 10 power 4, because denominator is 10 power 4, it terminates after 4 decimals, 4 decimal places. Hope you understood this. Now this question number 11 is very simple. It is a non-terminating recurring decimal. Every non-terminating recurring decimals can be converted into P by Q form. When when we are able to express a number in P by Q form, we call it as a rational number. So option B is correct here. It is a rational number because it is a non-terminating recurring decimal. Now next we have to decide 2 root 3. 2 root 3 is what? These all are very simple questions. Already you learned about these questions in class 9th. 2 root 3 is an irrational number. Clearly 2 root 3 is an irrational number because it is a non-terminating, non-recurring decimal. When you convert it into decimal form, it is an irrational number. For some integer q, every odd integer is of the form, every odd integer will be there in the form 2q plus 1. We can substitute any number in the place of q, we get all the odd numbers only in 2q plus 1. Remaining do not represent odd numbers. So 2q plus 1 is the correct option. Now question number 14. In question number 14, we have to find out HCF of A and B. Here already prime factorization is given. Prime factorization of A is x to the power of 3 into y to the power of 2, and prime factorization of B is x into y to the power of 3. So whenever we want HCF of A comma B, we write prime factors first x and y, and then we take their highest powers. Highest power of x is 3, so we write 3 here. Highest power of y is also 3. Okay, sorry, we have done wrong. When we find HCF, we take only common factors and their lowest powers. I thought it is LCM, but they are asking HCF, no. So when they ask HCF, we have to take common factors and their lowest powers. The lowest power of x, first you list out common factors. X and y are the common factors, and the lowest power of x is 1 and the lowest power of y is 2. So that is xy power 2 is the HCF of A and B. So option B is correct. Now coming to question number 15, it is about LCM again. So here we have to list out all the different factors in the prime factorization and their lowest powers. That is LCM of P comma Q. Here common factor, all the factors are A and B, so A into B we have to write, and now we have to take their highest powers. Highest power of A is 3, so we should write 3 here. Highest power of B is 2, so we have to write 2 here. So the LCM of P comma Q is A power 3 into B power 2, so option C is correct. Question number 16, it is a tree diagram. We have to find out the values of x and y. So let's find out y. When you want y, we have to divide 143. We have to divide 143 by 11. 143 by 11, when we divide, we get 11 ones 11, 3, 33, 11 3 is 33. So the answer is 13. So y is equal to 13. At the same time, similarly, when you want x, we have to divide 1001 by 143. 143 into 7 times, we get 1001. So x value is what? 7. X is 7. So x is equal to 7, y is equal to 13 is correct option. So whenever a tree diagram related question comes, we have to solve like this. Hope this is clear. Question number 16, 7 comma 13 is correct option. Now question number 17, here you can take one example and try, because they are saying that they are odd prime numbers. P1 and P2 are odd prime numbers. Any two odd prime numbers you take, find out the value and then check what answer you are getting. For example, let us take 7 and 5. 7 square minus 5 square, 49 minus 25, 24. What it is? Even number. So what we get? Even number we get. Like that you can try. So that is an even number. Option is A. Question number 17. Now let's see question number 18. In question number 18, we have to convert a non-terminating recurring decimal into p by q form. A non-terminating recurring decimal into p by q form. Generally we take that given number as x is equal to 0.134344 because bar is there for 2 digits. Because periodicity is 2, because 2 digits are repeating every time, we multiply 100 on both the sides, we get 100x is equal to 13.434343. After we are multiplying 100 on both the sides, we get like this. Then we subtract x from this. X is equal to 0.134343, so on, like this. So now after subtraction here we get 99x, and this is 13.3. Everywhere it will be 0. So 99x is equal to 13.3. X is equal to 13.3 by 99, multiply 10 in the numerator and denominator, we get x is equal to 133 by 990. This is actual method, but whenever it comes as a objective bit, we can solve it another way. What it is, the given number is 0.134 bar. So what we have to do, without a bar, write the total number once. First step, write the total number without bar. So that is 134. Then subtract the digits without bar. Subtract the digits that are there without bar. How many digits we have without bar? One digit, that is 1. So that 1 should be subtracted from whole number. So subtract that 1 from 134. We get 133. So this should be there in the numerator. Then what should be there in the denominator? Because bar is there for 2 digits, we need to write 2 9s in the denominator. So it is 133 by, because 2 digits, bar is there for 2 digits, you write 2 9s in the denominator. And then bar is not there for 1 digit after decimal, we have to keep 10 here. This is the result. This is the p by q form of 0.134 bar. So the option is D. Hope you understood this. Question number 18. Now question number 19. Which of the following has terminating decimal expansion? Which of the following has terminating decimal expansion? Generally, to decide terminating decimal expansion, we check the denominator. If the denominator is in the form 2 power m into 5 power n, where m and n are non-negative integers, that means what? If you have twos and fives in the denominator, only twos, only fives, or twos and fives combination in the denominator, that will be a terminating decimal. Otherwise, it is a non-terminating repeating decimal expansion. So if you observe here, the first one is, you can cancel. After cancellation it is 11. 7 11s are 7 30s are 11 by 30, which is 11 by 2 power 1 into 3 power 1 into 5 power 1. Here along with 2 power 1 and 5 power 1, we have 3 power 1 also. So it is a non-terminating recurring decimal. Non-terminating recurring, because it is not there in the form 2 power m into 5 power m. And this one already we have seen, same 23 by 30 is nothing but again 2 power 1, 3 power 1, 5 power 1, because 3 is there again, it is also a non-terminating recurring decimal. For 441 we have, that is 125 by 441 is 21 power 2, 21 square. 21 square means 3 into 7 whole square. So it is 3 power 2 into 7 power 2. Factorization of 441 is 3 power 2 into 7 power 2, which is again not in the form of 2 power m into 5 power n. It is also non-terminating recurring decimal. But this is 23 by 2 power 3. 8 is 2 power 3. You can write 5 power 0 because nothing is there. So this is a non-negative integer, means power can be 0 also. By this you should understand, when you have only 2 power something, or only 5 power something, or 2 and 5 both combinations, we can say that is a terminating decimal expansion. So this is what, this will have terminating decimal expansion. So which option is correct? Option B is correct. Option 19th option B is correct. Hope you understood this. Now question number 20. Question number 20, x is given, we have to find, x is given, we have to find out 2x. So x is equal to 0.777777 so on. We want 2x. That means what? It should be multiplied by 2. So what we get every time, so on. What we get? 7 2s are 14, 1. Again 7 2s are 14, 1, 15. Again 7 2s are 14, 1, 15. Every time we get like this. 0 point, no, 1 point. It will be like 1.55554. So that last one we will not consider. So finally we consider it as a 0.5 bar, because we do not know what is the last digit, what is we do not find last digit. So finally what we consider it, 1.5 bar only, because 5 will be repeated in this. So option B is correct. So these 20 bits are enough. Again in the next video we'll discuss about the remaining objective bits. Thank you.